Welcome to Unit 2 Derivatives, Lesson 6, Derivatives in Finance. In the business world, functions are used to model the financings of the company, and the key words we're going to use for this are as follows. We're going to go with revenue, cost, and profit, and we're going to look at the marginal revenue, cost, and profit. Sneak preview, marginal really means the instantaneous rate of change. So we're going to take the derivative of revenue cost functions and find its marginal revenue. Again, derivative will always lead to the marginal cost and marginal revenue and marginal profit. We're going to look at that as well. All right, let's continue. Here we go. The cost function, which is known as C of x, is the total producing x units of a product or service. The marginal cost, which is C prime at x, again, whenever I say marginal, I'm always taking the derivative. And this refers to the instantaneous rate of change of total products or total cost with respect to the number of units produced. Over here we can see that we would like to minimize our cost, of course, so we can see that the turning point will produce the minimum cost. So what we're going to do is we're going to set the marginal cost function equal to 0, and we're going to solve. And this, of course, works the same for revenue. So revenue, again, this is our R of x function, also known as, we're going to see this in the future, x, and x is number of units produced, and the P is actually what we call our, and again, P is called the demand function. We're going to see demand function in a few minutes. All right, and sold at a price of the unit of P of x. And again, P is our demand function. Marginal revenue is our prime at x. It refers to the instantaneous rate of change of total revenue with respect to the number of items sold. And again, for revenue, we always want to maximize revenue. So again, we're going to do the same thing. Maximum revenue will always be at the turning point at maximum point. So we're going to set our marginal revenue equal to 0 and solve. And then finally, the profit function. The profit function is P of x, and it's a profit from sales of x units for products and services. The product function is the difference between the revenue and the cost function. So revenue function and the cost function, and it looks like this. Revenue, or P of x, is equal to R of x minus C of x. Marginal, of course, refers to P prime at x, refers to the instantaneous rate of change of the profit with respect to number of items sold and also produced. Maximum profit, again, we set our profit function, the marginal profit function, equal to 0 and solve. Just a few notes here for the homework. Average cost is C of x over x, and average profit is equal to P of x over x, where again x is the number of units produced or units produced and sold. Of course, as a company, there's three terminologies we want to know here. P of x is greater than 0. We call this in the black. This basically means where the company is making money. P of x is less than 0. So greater than 0, making money, less than 0. That means it's in the red, and that means they're losing money. And if P of x is equal to 0, that means you're break even. Most companies in the first few years are in the red, and then they eventually make money. Well, hopefully, or else they cease to exist. But you always want to be in the black. All right, let's talk about the demand function next. So the demand function is the demand or price function, which is P of x. Notice it's lowercase p, really important here. Lowercase p, where x is the total number of units of the product or service that can be sold at a particular price p. So we're actually going to learn how to create this a little bit different than grade 10 math. So we're going to go back to a grade 10 math question, and we're going to solve it. But we're going to create the demand function this time. So again, a music store sells an average of 120 CDs per week. Mr. Wills, this is old. Why? We don't really buy CDs anymore. At $24 each, if you're selling CDs for $24, you are going to go to bankrupt. A market survey indicates that for each 75-cent decrease in price, 5 initial CDs will be sold per week. Alright, so here we go. We're going to let P be the price of one CD. And then X is also this number of CDs sold per week. Then N is the number of price decreases. So see, we've got here, if you notice, we've actually got 3 variables. But we want to make a P of X function. So what we're going to do first of all is we're going to start with 2 equations. We're going to do the number of products sold. So number of products sold will be, if I draw it out here, will be X is equal to, and we are going to sell here 120 CDs per week, but we're going to sell 5 more for every number of price decreases. So I'm going to put plus 5n. And then the price of one product will be this. The price, again, is P of that, or just P, sorry. The price is $24, but we're going to lower the price by 0.75. How many times, Mr. Wills? N times. So what we're going to do with these 2 equations, we're going to, in the first equation, we're going to isolate for n, and then once we isolate for n, we're going to substitute it into 2. So let's do that. Here we go. So for n, I'm going to isolate it. So I'm going to have here x minus 120 equals 5. N, then I'm going to divide all the terms by 5. So divide by 5, divide by 5, divide by 5. So here we're going to have, I'm going to go decimal here, 0.2x minus 24 is equal to n. So I'm going to take this equation here, and I'm going to substitute it into my other equation. So I'm going to put it into this equation here, because right now I've got x is equal to p is equal to, so p is equal to 24 minus 0.75 times 0.2x minus 24. But if you notice here, folks, everything here is in terms of x. So what can I do? I can then, I can then call this P of X my demand function. So this is going to be equal to 24 minus 0.15x when I multiply it out. And then here I'm going to do 3/4 of 24 is going to be 18, so plus 18. Add like terms, and so my demand function will be P of X is equal to 42 minus 0.15x. And so that is my demand function. And there we go. So that is how we do our demand function. We create a P, an X, and an N. We've got 3 equations, 2 unknowns. So what we're going to do is isolate for N in our product sold, and we're going to substitute that into our price per 1 unit. Alright, I'm going to stop here, and then we will continue in the next video.